Waves 4. Huygens principle. Very short one. So, who's Huygens? There he is. Long time ago, 1629 to 1695. Okay, and why we mention him in Waves is because he was a mathematician, and he looked at waves, and he was trying to explain how waves actually propagate. And so, for example, when you have a pond or a pool of water or something and you throw a rock in, you get a circular wavefront moving out. And Huygens analysed this, and his understanding is pretty much what we use nowadays, and we continue to use. And so his principle was basically to look at it in smaller and smaller detail. And so what he was saying was that all points on a wavefront produce secondary wavelengths, and it's the interference of all these secondary wavefronts that result in the wave progressing. So let's have a look at this. So there's our original wavefront, and so every single point on this wave then generates its own wave. So it generates a circular wave itself, like this. And so if we were to multiply, and here we've only shown a few of the new wavefronts, but if every point produced wavefronts, so if we zoomed in and in and in, we would see that there'd be constructive and destructive interference, and the net result would be we would get a new wavefront moving. And so they've exaggerated it here, but if we made it very, very small, and that's what he did mathematically, and he described the formulas that do all this, it works pretty well, and it explains how we get wavefronts propagating. So what relevance does that have to the modern world? Because he was way back in the 17th century. Well, some stereos use it. This is a sort of stereo that Yamaha produced and had the patent, but now you see them, if you go into Harvey Norman or other shops, you see these single bar stereo systems that are supposed to give you surround sound. Instead of having 4 lots of speakers, some behind you and some in front of you, these sound bars produce that effect. And what they are is they've got some big speakers to produce the more bassy tones, and usually have a subwoofer, but they have all these tiny little speakers, and these are all individually controlled. And what they do is they can make a directional beam of sound by producing sounds. So if a sound is being produced but it's staggered across the array, you get a sound front moving, and that's exactly what Huygens used, or Huygens principle. And so that wave front will move out in that direction, and so they can actually aim a beam of sound. And what these sound bars do is they take the signal and they produce beams of sound to bounce off walls, and when they bounce off walls they come from behind. And so if you're sitting here on the couch, you can get what's called 5.1 sound, and so that's the same as getting 2 speakers left and right, but also 2 speakers behind you left and right, and a center speaker or a subwoofer, and that's by bouncing the sound around. Quite clever technology, all happening digitally, very quickly, and so you don't really notice it, and they do work. Of course you've got to have a nice shaped room for them to work in, and there's only a sweet spot. But even with the 5.1 systems that have lots of speakers and things, there's still only one sweet spot that usually the person who sets up the speaker system knows and sits in to watch their videos and DVDs. Alright, so that was very quick, no questions related to that, but it's important that you understand that principle. And in the next video we'll be looking at reflection.